Is it visible to you, everyone?
Yes, sir. Yes, sir.
So welcome all of you to the next second session of 8086 microprocessor. So right now I will discuss about the addressing modes of 8086 microprocessor. Now, first of all, what is addressing? What does it mean? And why it is so required, so important in 8086 microprocessor. Now, for every microprocessor, there are certain addressing modes. Okay, so first of all, what is addressing? Addressing means where the data is located. Okay, where it is situated. Now, if someone is asking you what is your address, you need to tell them that your home address, okay, or where you have reside right now. So that is the address. So here in this context, in this microprocessor, now where is the location or how the data can be accessed? The way for locating the data is different addressing, using different addressing, and that is called the address. Okay, address means where the data byte has been stored or how they can be located. So that is called the addressing. Now the various ways are there to locate the address. Like one data can be stored in register. One data can be fetched from the memory, or one data can be in any other ways from the external side. It can be transferred to the microprocessor. So there are various ways to locate the data bytes, and these ways are actually called addressing modes. Okay, so different modes are there to address the data. That's these are called addressing modes. Now you have in 8086. Okay, so addressing mode indicates a way of locating data or operands. Depending upon the data type used in the instructions, some instructions may belong to the more than one addressing mode, or some instructions are not included in any addressing modes. So the addressing mode actually describes the type of operands, whether it is immediate or it is register based, or it is from indirect memory access, and the way they are accessed for executing an instruction. Okay, so the addressing mode describes the types of operands and the way they are accessed for executing of such instruction. Now there are different addressing modes present in 8086. So listen very carefully. Somehow it will be complex compared to the previous topics. So listen carefully. So there are total 10 addressing modes. First of all, the immediate addressing mode. So what is immediate addressing mode? Mm, Okay, the 10 addressing modes are in this way. The first is immediate addressing mode, second is the direct addressing mode, third is the registered addressing mode, fourth one is registered indirect addressing mode, indexed addressing mode, register relative addressing mode, based indexed addressing mode, relative based index addressing mode, and the inter segment addressing mode and intra segment addressing mode. Now within inter segment addressing mode there are two modes: inter segment direct and inter segment direct indirect. And intra segment addressing mode, same, in this mode there are two different modes: intra segment direct and intra segment indirect. So I will discuss one by one of these addressing modes with examples. So the first is the immediate addressing mode. In this addressing mode, the data byte which is specified directly into your instruction, like uh, in 8086 you can access 8 bit of data, in 8086 you can access 16 bit of data. Now if as per your requirement you can access any size of data, between 8 to 16. Now if you want to access such type of data, whether it is 8 or 16, like 8-bit data can be accessed in this way: move al comma 50. So 50, that is in hexadecimal number system, so 50 can be loaded inside al register. Okay, so in that case you need to write it as move al comma 50. Now if any 16 bit of data like 23a0, here in this case you need to load this data inside any 16-bit register. You can use AX or BX or CX or DX, because as you know that we have general purpose registers as AX, BX, CX and DX. AX is divided into AH and AL, which is 8-bit and 8-bit, lower 8-bit and higher 8-bit. BX in the same way, BX is divided into two registers, 8-bit register, BH and BL. In the same way, CX is CH and CL and DX is DH and DL. So you can use any 8-bit register like AL or AH, or combinations of these two 8-bit registers like 16-bit as AX. So here you have used 50, which is 8-bit number or data. That's why AL is used. You can write it as move AH comma 50 also, no problem. You can write it as BH comma 50. You can write it as BL comma 50, DH comma 50, DL comma 50, or CH comma 50 or CL comma 50. In the same way, this for the second instruction, like move BX comma 23A0, you can write it as move AX comma 23A0 also. You can write it as move CX comma 23A0 and move DX comma 23A0. Okay, so using general purpose registers you can assign this data, or you can loaded this data inside any general purpose register as per the data size. Okay, now the difference between now what is happening in 8085, the previous microprocessor, like to load inside any register any number, you need MVI related instruction, and to load any 16-bit of data you need LXI related instruction. Okay, so in 8086 there is no I related instruction. Most of the instructions are related to uh, without I related instructions, like there is no MVI. All move instructions are using simple MOV related instruction. There is no MVI. All the instructions are related to move instructions are MOV related instruction. MOV related instruction. Clear? That is the difference between 8085 immediate addressing mode and 8086 immediate addressing mode. In 8085 you can use MVI A comma 50, whatever, and or B comma 50 or C comma 50, anything, but it is related to MVI or LXI H comma 1234. But in 8086 there is no I related instruction. All the instructions are related to immediate addressing mode using move, MOV, simple MOV related instruction. Yeah, is this clear?
Yes, sir.
The next next addressing mode is direct addressing mode, where directly the memory address is specified into your instruction. Like here in 8086 microprocessor, this third bracket, this bracket represents, within this bracket what is written, that is not any data byte, it is not any data, it's a memory location. Inside this memory location there has been a data. Clear? So the instruction is written as move ax comma within bracket 5000h. Okay, so 5000 here, it signifies that it's a memory location where some 8 bit some data byte has been stored, and that data should be transferred to the AX register. Okay, to the AX register.
কোথায় খেলা তুমি অনেক কিছু দেখেছো
Is there any problem?
স্যার মিউট করে দিয়েছে ভিতরে
So I will mute all. Okay, after delivering my lecture I will discuss, I will ask you the questions. Okay, so second instruction, second addressing mode is direct addressing mode. Now in this addressing mode, move ax comma within third bracket 5000h. Now this 5000 is your memory address where some data byte is present. Now that data byte, suppose in 5000 memory location 20 is there, 20. Now 20 will be moved to AX register. Now AX register is your 16-bit register. How this 20 will be loaded? Now 20 will be loaded inside AL register, and by default AH will be filled up with 00. Clear? And if you want to access 16-bit data at a time, so you need two consecutive memory locations, and in this case 5000 and 5001. So these two memory locations, corresponding two memory locations, are used to store 16-bit of data, 8-bit in 5000 and another 8-bit in 5001. So when this instruction will be executed from two memory location, both 8-bit 8-bit, total 16-bit with loaded inside AX register. First of all, 5000 data byte which is present in 5000 memory location will be loaded inside AL, and the data byte which is loaded which is stored inside 5001 memory location, the second data byte must be loaded inside AH register. Okay, so 16-bit full 16-bit register will be loaded by the memory location content, two consecutive memory location content. So here 5000 is given directly into your instruction, that's why it is in under direct addressing mode. Clear? The third addressing mode is register addressing mode, where register to register operation can be performed, and it may be move BL comma CL, AL comma BL, DL comma CL, or move AX comma BX, BX comma CX. So any register to register, or add BL comma CL. So these are the example under register addressing mode, where register to register operation is performed. The first register is your destination, and the second register specified the source. So add CL comma BL means addition between the content of CL and content of BL, and the result will be stored inside CL. Now one thing you have to remember, that in 8086 the operations are not all accumulator oriented operation. Okay, like in case of 8085, all the arithmetic and logical operations are based on accumulator oriented, so that automatically the result will be stored inside accumulator, and by default one data byte must be stored in accumulator, and second data byte can be from any register within that programmable registers, 7 programmable registers. Okay, but here that is not mandatory. Any register can be added to anyone, and any register can be used to store the result. So which will be specified as your register initially? First one, that is your by default register, where the result, or that is the destination register where the result will be stored automatically. Like add CL comma BL, so CL will be added to BL, and the result will be stored inside CL. Now ADC BX comma DX means add content of BX and DX and the carry flag, and the result will be stored inside BX. So which is specified into your instruction, which register is specified first, that will be always is your destination register. and the second register specified as your source. Okay? The next addressing mode, is register indirect addressing mode. Register indirect addressing mode means here memory location will be specified, but it is not directly, it is indirectly specified. Like we have used in 8085 microprocessor in indirect way. That means HL, some register pair has been there to initialize or to point some memory location indirectly. Like LXI H comma 1234. Now this 1234 will be your memory location A if and only if M related instruction can be used into your program. So if LXI H comma 1234, then I have written move A comma M. What does it mean? The M relates to the memory location which is pointed by HL register pair, that is the 1234, that is your memory location. From this memory location the data byte will be moved to accumulator. Clear? So it is indirectly specified. So M related instructions are it was under indirect addressing mode. In the same way, for in 8086 microprocessor, the BX register is default. It's one type of offset register where offset address will be stored. Now offset address, that is the address that will be incremented or changes by the microprocessor every time when any instruction or data byte fetched from the corresponding segment. Okay, so BX register, that is the general purpose register obviously, but it can be used for base address purpose also. So it can be used as a general purpose register as well as special purpose register, like it is used to store the offset address, or it's called the offset register. It can be used as your offset register. So here I have written that move AX comma BX, that is within bracket. Now within third bracket, this third bracket represents what is within this, that is the memory location. Now memory location is not given directly, so memory location is specified or it is stored inside BX register. Now BX register points some memory location. From that memory location, the data byte will be moved to accumulator. Clear? So if BX contains suppose 5000, okay, or 6000. So BX contains 6000. Now 6000, that is the memory location where suppose 10 is stored. Now that 10 or two consecutive memory locations, if 16 bit is there, then 6000 and 6001, these two consecutive memory locations are used to store the 16 bit at a time, and it will be loaded inside AX register. Yeah. So if in 6000 memory location 10 is there and 6001 11 is there, then what will be the content of X? 1110. So upper 11 is in H register, and lower 10, that is 10, that will be loaded inside AL register. Clear? So combinations of these two registers, it creates a 16-bit register which loads a 16-bit content. Is it clear? Next is the indexed addressing mode. Now according to this name, how many index registers are there in 8085? 2. One is the SI register and second is DI register. SI and DI. So source index is there, destination index is there. Source index, that means you can use these memory locations as your source memory location purpose, and destination index, these are called to store something inside that memory location as your destination purpose. So you can use any one of them. As it is used by the index register, that's why it is under indexed addressing mode, and the instruction can be written in this way. Example, move AX comma under bracket SI, or you can write it move AX comma DI, or SI or DI can be used as per your segment, as per your offset register. Clear? But that is the index register, index, source index, destination index. So if index registers are involved into your instruction, that means this instruction is under indexed addressing mode. Is it clear? Okay. Now one thing, up to this much, so do you have pen and paper with you? Do you have pen and paper with you?
Yes, sir.
Okay,
Yes,
so
sir.
write down. Everyone must write down. So until now, I have uh, given some examples of 5 addressing modes. Okay. Now, take any addressing mode in this way. Can you remember how? Can you remember the physical address generation? Physical address generation, 20-bit physical address. You need 2 addresses. One is the segment address, another is the offset address. The formula, what is the formula? Physical address is equals to segment address into 10 plus offset address. Is it clear? Now, take any example. Like this one. Like this one. Move AX comma 5000. Within 5000, there may be some data byte. 5000 and 5001, whatever. 5000, take it as 20. In 5000, there is a 20. Now, how can you calculate the physical address for this instruction where the data byte is there? If assume the segment is as DS segment DS data segment, which is equals to 2000. Okay, so here this 5000, that is used as your offset address. So segment address is given as DS, which is equivalent to 2000. DS equals to 2000, and your offset address is equals to 5000. Then what will be your 20-bit physical address? Calculate it and tell me the result. Everyone, calculate it. DS is equivalent to 2000.
তুমি যাও তো তুমি এখান থেকে ফালতু আর কি মারো তোমার
So DS is equivalent.
বিতানু প্লিজ মিউট কর।
বিতানু ভাই ভালো আছিস?
Don't talk. So DS equivalent to 2000 and offset is equivalent to 5000. Then tell me what will be the 20-bit physical address. 20-bit physical address. What will be the 20-bit physical address? Anyone? What will be the 20-bit physical address? Anyone? Have we calculated it? Yes. No. Segment. Anyone else? Anyone else? Okay, so 20-bit physical address. Please check the answer. All of you. 20-bit physical address will be your DS is given as 2000. So 2000 into 10. 2000 into 10 H plus 5000 H, which is 25000. 25000 H. So 25,000. That is the 20-bit physical address. Okay, so that is the actual location where your data byte is present. Clear? So in this way, so what is given as your segment address, that will be that must be multiplied by the 10 H plus offset address must be added to it. Okay, so your 20-bit physical address for this example is 25000 H. Is it clear? For the second, for the third one, okay, for the fifth one, in this example, uh, if DS segment is used as your segment register, segment address DS, and assume DS is equivalent to 3000, and SI, which is used as your offset register, which is 1000. So DS is 3000, SI is 1000. Then what will be the physical address? So your physical address is
310008.
31000. Okay, so 31,000. Is it clear? 31,000. Is it clear?
Yes, sir.
Yes, sir.
So coming to the next addressing mode, which is the register relative addressing mode. Register relative addressing mode. Now, as per this, according to the name, register must be involved. Some register. Which register? That register which is used as your offset register or base register. Only one general purpose register that can be used as your offset register. You can't use AX as your offset register. You can't use CX or DX. Or you can use only BX register as per your offset register. Clear? All other offset registers are instruction pointer, stack pointer, base pointers, source index, and destination index. These are offset registers. Clear? IP, SP, BP, SI, DI. These are genuinely or specifically offset registers. It has no other function. But AX, BX, CX, DX, these four registers are general purpose registers. Among these four registers, only BX has dual function that can be used as your general purpose register as well as special purpose register. And what is the special purpose? The special purpose is to use this as your offset register. So BX can be used as your offset register. Yeah. So BX register is called the base register. So there must be base register in this type of addressing mode. The instruction should be written in this way: move AX, 50H, then within third bracket BX. So third bracket, within third bracket means it is a memory location indirectly given. So register must be involved, and which register can be used? Only BX can be used in this purpose. You can't use AX. Okay. You can't write within bracket AX, you can't write CX or DX. Only you can write BX within third bracket. So BX is assumed as some memory location it is pointing by, and 50, that is called the displacement. Here you can use, what is the size of this data byte? It is 8-bit. 8-bit displacement, 8-bit displacement can be used, or 16-bit displacement can be used, like 5000 can be used here. No problem, anything. Now, what is displacement? Displacement is the distance. Displacement is the distance. Suppose that is, it is your segment, total segment. Within this segment, offset addresses will be changed one by one. Here, now I have given that my data byte is present in this position, top position. So I need to go this much distance. Okay. Now, if this distance, and this distance actually called the offset. Now, if this distance is divided into two parts, one is given as your displacement and another is given in your offset register. Clear? So your distance is divided into two parts such that half portion is given directly as your displacement, like this one, and another portion is given in your directly into the offset register. So in this case, what will be the physical address? In this case, what will be the physical address if DS segment is used? Suppose DS segment is 3000, BX is equivalent to 2000. What will be the physical address? Everyone must write down. It's very, very important for this example also. Physical address will be, okay, first write down topmost of your copy. The DS is given, DS is equals to 3000, DX is 3000, BX, this register, BX base register equals to 1000, displacement equals to 50h. So physical address will be 3000 into 10h plus bx is 1000, that is plus 1000 plus 50. Clear? So segment address into 10. So segment address is given as 3000. So 3000 into 10 plus offset address. Offset address is given as 1000 and another offset is given directly as 50. Okay. So the combinations of these three, it creates one complete address, and that is the real address, which is 20 bit in size, 20 bit physical address. Clear? If in spite of 50, if it is given as 5000, then what will be the physical address? In that case, this will be 3000 into 10 plus 1000 plus 5000. Clear? So actually, what is the use of this 5000? This 5000 is a displacement, means the distance. Now you have to go such 5000 distance, then you have to go 1000 distance, and after that you can reach to that level where the data byte is present. Clear? So your total offset means the distance from the base point to the most topmost point where the data byte is there. So this is called the offset. Now this offset can be given directly into some register, or this offset can be separated by two ways. One is given as your displacement, another given as inside your register. Clear? Is it clear, everyone?
Yes, sir.
Yes, sir.
So go to the next addressing mode, which is based indirect addressing mode. Now, according to the name, there must be one base register, which is BX. There must be one index register, which is source index. And what will be the instruction? You can write it as move AX, comma BX within third bracket, then SI within third bracket. Base index addressing mode. That's why it is called base index. So under this type of addressing mode, the instruction should be written in this way. There must be one base register and another will be your index register. Clear? Next, so in this case, okay, so in this case, what will be the physical address? Your physical address will be, if DS as your segment address, so DS into 10 plus BX plus SI. Clear? Your offset is divided into two parts. One is stored inside the base register, another stores inside the index register. Clear? Now come to the next one, which is relative based index. Now relative means there must be one displacement, either 8-bit displacement or 16-bit displacement, and there should be one base register and there should be one index register. So what will be the instruction? Move AX, comma your displacement within bracket BX base register within bracket SI index register. So it is called relative base index addressing mode. Relative based index. It can be written as this one also. Move AX, comma 5000, then BX, then SI. Clear? Now next is the inter-segment addressing mode. Now inter-segment or intra-segment addressing mode. There are nine classification is 9. Number 9 is inter-segment and 10 is intra-segment. Inter-segment and intra-segment. Inter-segment is this one where your program control is transferred to a different segment. Okay, from one segment to different segment. Like in case of jump instruction, branching instruction, what happened? The program control is transferred. Suppose it is in sequential manner, it is executed. The microprocessor executes the instruction one by one. Now at certain level, it creates to jump to such memory location, then execute the instruction. So program control is transferred from this location to this location. Clear? So by skipping some of the instructions. Now this inter-segment addressing mode is such that where your jump will be there from one segment to another segment. You have 4 segments, and code segment is your 64 kilobytes. If code segment is given as 3000, okay, your offset will be changed in this way. If code segment is changed from 3000 to 4000, So your program control will be transferred from 3000 code segment to 4000 code segment. So one segment to another segment, it goes from one segment to another segment. That's why it is called intersegment. Okay. And intra-segment means if your program control is transferred within the same segment, clear? Like in short, in easiest way, the jump instruction, always in 8085, jump instruction will be executed within one single program. In case of call instruction, it is executed in main program and call the subroutine or sub program, which is stored inside any other memory locations. So your memory location has been changed from one current program to another program. Like here also, intra segment means your program control will be transferred from one position to another position, but your segment is fixed. Within this segment, you have to change your program control location. Okay, so your execution control will be changed from this position to this position, but it is within the one segment. It is not change the segment from one segment to another segment. So intersegment means the different segments. From one segment to different segment, the program control has been transferred. And intra-segment means within the same segment. Yeah, within the same segment. Like intersegment, if it is between two different segments, then intersegment direct addressing mode is written in this way: JMP 5000 is to 2000. Means this JMP is written in some segment which is 3000. So when microprocessor reaches 3000 memory location, and in this memory location this instruction is been written, so it goes it executes from 3000 to 5000. So your segment is changed from 3000 to 5000. Yeah, and within this the offset will be changed as 2000. Clear? So this is the direct addressing mode where your segment address and offset address is given, and always it is given using this type of representation. So 5000 is to 2000. Now in case of indirect addressing mode, the address must be given within the bracket, That's why it is called indirect addressing mode. Jump to such segment which is under this category 2000. So these two examples are based on intersegment, means program control is transferred from one segment to the another segment. Clear? And intra-segment is the within the same segment. So direct under direct mode, the programming execution control location must be given in such way that your the value of that location must be within the range. Now in case of any sign bit operation, the range is for 8-bit sign bit operation, 8-bit data, the range is within -128 to +127. Means total 256 numbers are there. If a number is 8-bit in size, so how many combinations will be there? 2 to the power 8 means 256 combinations will be there. So if it is sign based number, so there must be some positive numbers and there must be some negative numbers. So 256 total number is there. So 128 numbers will be positive and 120 number will be negative. Yeah. So positive numbers is started from 0 to +127 and negative number is started from -1 to -128. So upper portion there is 128 numbers, 0 to 127 means 128 numbers, and in lower portion -1 to -128, that is another 128 but is in negative form. So in sign number operation there must be some positive numbers, some negative numbers, but the total range is 256 numbers. So you have to calculate in such way that your program location will be within this range. So it is in decimal form, -128 to +127. If it is in hexadecimal number system,